Okay, so here is a theorem from analysis. Now, this one is much, much more complicated than the ones I showed you. So that's why I'm probably just going to send a video with the actual theorem, and then the proof will come separately because it's kind of long. But this is the theorem itself. So it states that if f is a monotone function on the interval a to b, then the integral, the definite integral, from a to b of f exists. So it exists, that's one thing. And furthermore, if you take a sequence of partitions, we'll call that pi sub n, from n equals 1 to infinity. So we let this thing, we say it's a sequence or any sequence of partitions of a comma b with a special property. Now, it's not just any sequence. It's got to have this special property right here. So the mesh of the partition pi sub n, the mesh represents the mesh is like the width of the interval. That's what the mesh means. So as the mesh of the partition pi sub n approaches 0, we say that it approaches 0 as n approaches infinity. So as n gets infinitely large, then the mesh gets infinitely small. Now, so that's part of the condition we have. And if you take another sequence, sigma sub n, we say it's any sequence associated. So it's a sequence of associated selections. So I know this sounds kind of weird. Let me write it over here. So we have an interval like this. Then we take some partition pi. So all these little divisions, that marks pi sub n. Then we take a sequence of associated intervals. So these are like smaller ones that are in between all of the elements. Now remember, I just showed you one sequence here. This represents an infinite number, okay? It's an infinite number of sequences. So it's more abstract. It's not just a little picture. So remember, it represents an infinite number of sequences because pi of sub n goes from n equals 1 to infinity. Okay, so anyway, so as the mesh of pi sub n approaches 0, this approaches 0 as n approaches infinity, and if sigma sub n is any sequence of associated selections, then, I underlined this because this is super important. This is the if part of the statement. If you have all of this, then the Riemann sum of the function f with interval pi sub n with associated selection sigma sub n approaches, so the sum approaches a definite integral from a to b of f of t dt. That's the theorem. Now, I was writing out the proof, but I might run out of time. I can only make 3-minute videos. So it took me 3 minutes just to state the theorem. To prove it might take longer. We'll see.